Hi guys, welcome back to the channel, Mick the Mechanic here, what's up? So today we're going to talk about the coding and the electrics for my compressor project. First of all, I finished the circuit board. I managed to squeeze everything onto the circuit board. It was a tight fit, but managed to get it all squeezed in there between the display shield and the Arduino Uno. I also changed the schematics a bit. I'll show you the updated schematic now. I've added some LEDs. They're small bicolor LEDs. One just replaces the board mount SMD LEDs on the lithium charger to show status for the battery, if it's charging or if it's fully charged. If it's fully charged, it will be blue. If it's charging, it will be red. And I also added an LED to the transistor for the relay, so if the relay is switched on, the light will be red, and if it's switched off and the tanks are full, the LED will be green. Yeah, I managed to fit it all into the housing. You can see it fits perfectly in there. It's a bit of a tight squeeze, but it's looking good. I've got connectors for everything, so I can disassemble if needed. It's not hardwired in there or anything. So moving on to the code. I'm using a library called GUI Slice. This is specially designed for creating GUIs. I'm using it because they have a ring gauge widget available. It looks super cool, and I want to include this in the Arduino. But first of all, we need to make some space because the Arduino has got very limited memory, and the ring gauge takes up a lot of memory along with the GUI Slice library, which is also dependent on the independent display drivers. In this case, we're using MCU fence drivers in conjunction with GUI Slice. I've been in contact with the creator of GUI Slice, Calvin, and he helped put together a special code. So it's actually a custom ring gauge widget that uses a simplified math basically to draw the ring gauge. It saves a lot of memory because we're actually at 99% memory with all of these things. So also the code is a tight fit on the Arduino Uno. I didn't want to upgrade because yeah, I'm pretty bad with this type of stuff. If I got it like an ESP32 or something, before you know it, it would not just be a compressor, but also be a weather station with a web server or something like this, and things get really out of hand fast. So I'm terrible. So now that we've made some space, we need to add just a normal code. It's super simple. We just define the pins that we're using, and we just write some super simple code. If the signal from the sensor is less than this amount, we switch the relay on, so we write the pin high. If it's more than this amount, we write the pin low again. Super basic stuff. We've got a countdown timer. In this case, we're counting loop cycles because we can do this with an 8-bit integer. If we were going to use milliseconds and the built-in timer, then we would need some unsigned longs. These take up a lot more space than just an 8-bit integer. I think they're like 64-bit or something, I'm not too sure, but it's a lot more space. So that's the hack for that. We're just using this 8-bit integer to count loop cycles with a delay in there, and we can roughly calculate how long. And I actually timed it. It stays on for about 15 seconds now, which seems pretty good. So here we are testing the device. As you can see, it seems to be working. I've added a potentiometer where the pressure sensor would normally attach. This works perfectly because the pressure sensor normally provides a signal, an analog signal from 0.5 to 4.5 volts. We can simulate this for testing purposes with the potentiometer, and with this connected, we can slowly increase the pressure and we can see the light change. We can also hear the relay turn on, so everything seems to be working fine. The timer is also working fine. If I press the button, it stays on and it switches off by itself. Connected to 12 volts now to my lamp power supply. You can see, first of all, reverse polarity protection. If I connect the leads the wrong way, nothing happens. If I connect them the right way and press the button, the device powers up and we can see the status LED for the battery. Red is charging and blue is fully charged. So everything's working pretty nice. That's all for today, guys. Just another update. I'll post another update soon with the compressor fully assembled and doing some real life tests. So that's all for now, guys. Mix the Mechanic here, signing off. Like and subscribe, please. It helps me out a lot. And yeah, stay tuned for the next episode.